Hey guys, in this video, we're going to discuss Leetcode 560, where we need to find the subarrays that having the sum equals to k. So for this problem, we're going to have two input parameters, an array of integers, and then a target value k. So basically, we need to find the number of subarrays that having the sum equals to k. So usually the keyword here is the subarray, right? So usually for subarray problems, the most common algorithm we're gonna use to solve this problem is to use the running sum map algorithm. So basically, running sum map algorithm is like we need to keep track of the current sum from index 0 to index I, and then store it in the map. So how it works is like if the current sum from index 0 to index I is 10, right? And then if in the map there is a sum from index 0 to index j is 7 and j is smaller than I, then we can know for sure like from index I to j, the sum is 3. So basically as we loop through every number in the numbers array, we just keep track of the current sum and then store it in a map so that we can know we can know all the subarrays, like if it exists in the map that equals to sum 3. So basically, we can just keep track of the current sum, and then need to know what number we need to subtract from the current sum to get a target value. And if the numbers exists in the current running sum map, then we know like there is a subarray exists. So the key will always be the sum from index 0 to the current index I in the running sum map. And then the value will be, since for this problem, we need to find the number of subarrays. So that's why the value would be the number of occurrences for this sum. So let's walk through this example. Let's say the input is 1, 2, 3, and the target is 3, and then let's examine like how this algorithm works. So firstly, we need to initialize the running sum map as 0 to 1, which means the sum is 0 and the occurrence is 1. This is because like if we having the, like for example, like 1 and 2, right? The subarray like starting from index 0 to index I is equal to target. Then we know like it was starting from index 0 to index I. So there's nothing to subtract from this. So that's why we initialize it like the sum 0 and the occurrence of 1, because if we select nothing from the array, then the sum will be 0, and then it will always for sure like exist as an occurrence of 1, because like starting from index 0, our target subarray will start from index 0. That's how we initialize it here for this problem. So 0 and 1, so occurrence of 1 for sum 0. And then let's say the current number is 1, right? So let's loop through the numbers array. So the first number is 1. So the current sum from index to the current index will be, the current sum will be 1. And then the target value we need to subtract to get the target value 3 is like -2. So do we have -2 in the map? No. So that's why we don't update return the number. So that remains 0. And then after this, we update this sums array. So 1 to 1. So which means we have a subarray of sum 1, and the occurrence is 1. Now we loop through the second number, which is 2, right? So now the current sum will be 3. So what's the value when you subtract to get target 3? 0. Does 0 exists in the map? Yes. And how many occurrence of 0 we have? It's 1. So that's why we increment this by 1. All right. Now we loop through the third number, which is 3. And the current sum will be from index 0 to current index would be 6. And what's the value we need to before that, we also need to update this running map sum 3 to 1. So which means from the occurrence of sum 3 from index 0 to index I would be 1. So that's how many subarrays subarrays starting from index 0 having a sum of 3. There's one of them. All right, let's loop on to the next number, which is 3. So next number is 3. So now the total sum will be 6, right? So the value we need to subtract to get target 3 is 3. So 6 minus 3 will be 3. Do we have 3 in the map? Yes. And what's the value for it? 1. So we just increment it by 1 as well. So the total value total number of subarrays is 2. So, and then like this is the end of the numbers array. So what's the value to return is 2. So this is why we return 2 here. So basically this is the algorithm we're gonna use to solve this problem. So let's start code it out. All right. So first of all, we need to have a running map sum, right? So let's say running sum map, and let's say we have a use it default dict. So it will be the value would be a count, the number of occurrences for the sum. So that's value would be integer. All right, and we initialize it to initialize it for sum of 0, and the value would be 1. All right, and then we have the current sum, initialize it to 0, and then the result return initialize to 0, right? And this is what we need to return. All right, now let's start looping through the numbers. Current sum would equals to current sum as a number, and then the remaining value, the target, the value to subtract to get target, right? So value to equals to current sum minus k. So this is like how much we need to subtract from current sum in order to get k. All right. So and the result will just equals to occurrences. Equals to running some map for its value. The result just incremented by the occurrences. By the occurrences. All right, and after that, we need to update this running sum map, raise this current sum, incremented by 1. So basically, this is the algorithm we're going to solve it. So basically, what we do is we initialize the running sum map and initialize 0 to 1, which means like for the subarrays, basically it's for the subarrays like starting from index 0. It will be used for subarray starting from index 0. And then when we loop through the array, we just keep track of the current sum from index 0 to the current number. And then this is what we need to subtract in order to get target value k. And then we just in the running sum map, we just see like how many occurrences for that we have. And then the result like will just incremented by the occurrences for that value to subtract. And then we just, after that, we just need to update the running sum map for the current sum and update the occurrences by 1. Let's see how it goes. Should be working fine. Yep, looks good. So basically, like this is a code, and then the time and space complexity both would be linear because we have a like order of n, because like we have a loop which is order of n, and then we have a map which is order of n for the space. Okay, so this is the end of the video, and I'll see you guys in the next one.